Mars has been a focus of planetary exploration since the dawn of the space age for three main reasons. 1. It is the most Earth-like of the planets. 2. It is the planet other than Earth that is most likely to have developed indigenous life. And 3. It will likely be the first extraterrestrial planet that humans visit. The exploration of Mars was a primary goal of both the American and Soviet space programs from 1960 and 1980. American spacecraft successfully orbited Mars. Mariner 9 and Vikings 1 and 2 flew by Mars, Mariners 4, 6, and 7, and deployed lander modules there, Vikings 1 and 2. Two of the three Soviet rovers that explored Mars' surface, Mars 2, 3, and 5, investigated the planet. On December 2, 1971, Mars 3 became the first spacecraft to soft land an instrumented capsule on the planet. It did so in the midst of a global dust storm and sent data for roughly 20 seconds. Mars was orbited by Mariner 9, the first spacecraft to do so, in November 1971, and it was in operation until October 1972. A comprehensive range of spectroscopic, radio propagation, and photographic data were returned. Over 7,330 images, or 80% of the surface, revealed a history of widespread volcanism, ancient water erosion, and substantial surface modification by internal processes. The quest for extraterrestrial life was the main focus of the Viking expeditions. The numerous equipment on the two orbiters and the two landers gave detailed data on Martian geology, meteorology, and the physics and chemistry of the upper atmosphere, but no conclusive evidence of biological activity was discovered. June and August 1976 saw the launch of Vikings 1 and 2, respectively. After finding suitable locations, the orbiters released the lander modules to land on the ground. On July 20, 1976, Viking 1 touched down in the area of Christ Planitia, 22 degrees north, 48 degrees west, and on September 3, 1976, Viking 2 touched down in Utopia Planitia, 48 degrees north, 226 degrees west, which was 6,500 kilometers, 4,000 miles, distant. Soviet researchers launched the Phobos 1 and 2 spacecraft in 1988 to circle Mars and conduct slow flyby investigations of its two satellites. Phobos 1 was lost throughout the entire year-long mission, while Phobos 2 made it to Mars at the beginning of 1989 and sent back several days' worth of observations of the planet and Phobos before breaking down. Many American spacecraft missions to Mars in the 1990s ended in failure, but on July 4, 1997, Mars Pathfinders successfully landed in Christ Planitia, 19 degrees north, 33 degrees west, and sent down a robotic wheeled rover dubbed Sojourner. Mars Global Surveyor, which arrived on Mars in September 1997 and began mapping the planet's numerous characteristics from orbit starting in March 1999, came next. These included the geography, minerals, and magnetic and gravitational fields of Mars. Additionally, the spacecraft was equipped with cameras that could capture wide-angle and detailed photos of the surface at a resolution of 1.5 meters, 5 feet. In October 2001, Mars Odyssey successfully orbited the planet and began mapping other characteristics, such as the surface's chemical makeup, the location of near-surface ice, and the physical characteristics of nearby objects. The polar regions above latitude 60 degrees may have enormous underground stores of water ice, according to neutron observations. By demonstrating that the temperatures of the cave entrances, which appeared as black circular marks, did not shift as much as the surrounding surface, Mars Odyssey also revealed tunnels on a volcano. In late 2003 and early 2004, a flurry of spacecraft approached Mars with varying degrees of success. The first spacecraft to approach the planet's proximity was Nozomi, which Japan launched in 1998 on a leisurely course. Unfortunately, problems prevented it from being placed into Mars orbit. The Mars Express mission of the European Space Agency set off for the Red Planet in the middle of 2003. it entered Mars orbit on December 25th with instruments to study the atmosphere, surface, and subsurface. However, its British lander, Beagle 2, which was intended to look for evidence of past or present life in the rocks and soil, was unable to make radio contact after landing on the Martian surface the same day. The Mars Express orbiter discovered large fields of water ice and carbon dioxide ice at the southern pole just a few weeks after it arrived, confirming that the southern summer remnant cap, like the northern one, includes permanently frozen water. Additionally, it discovered clay minerals in the severely cratered terrains as well as significant sulfur-rich deposits, mostly in the Valles Marineris. In the spring of 2021, when NASA's Perseverance Mars rover started studying rocks on the floor of Jezero crater, the scientists discovered something unexpected. They had anticipated discovering sedimentary rock, which would have formed as sand and mud settled in a formerly watery environment because the crater had once hosted a lake billions of years ago. Instead, they found that the floor was composed of two different types of igneous rock, one of which was created by volcanic activity on the surface and the other by the formation of magma deep down. The discoveries are detailed in 4 fresh articles released on Thursday, August 25th. A second study in the same magazine, Science, describes unusual rocks that appear to have developed from a thick mass of lava. One study in the journal provides an outline of Perseverance's exploration of the crater floor until it reached Jezero's ancient river delta in April 2022. The other 2 publications describe the novel ways that Perseverance's rock vaporizing laser and ground-penetrating radar established that igneous rocks blanket the crater floor. Both papers were published in Science Advances. Crystals found in igneous rocks serve as effective timekeepers by preserving information about the precise moment of formation. The igneous rocks we found have a lot of importance because they can tell us when the lake was present in Jezero. According to Ken Farley of Caltech, the project scientist for Perseverance and the primary author of the first of the 2 science studies, we know it was there more recently than the igneous crater floor rocks produced. This will answer some important queries. When did Mars' climate evolve to the extremely chilly and dry conditions we see today, and when was it favorable to lakes and rivers on the planet's surface? Igneous rock isn't the best material to preserve the possible traces of prehistoric microscopic life, though, due to the way it forms. In contrast, dating sedimentary rock can be difficult, especially if it includes rock fragments that developed at several points prior to the deposition of the rock sediment. However, sedimentary rock frequently originates in wet conditions that are favorable for life and is better at preserving prehistoric life traces. That is why scientists have been so intrigued by the sediment-rich river delta that Perseverance has been exploring since April 2022. In order to potentially send sedimentary rock core samples to Earth for analysis by powerful lab equipment that is too huge to travel to Mars, the rover has started drilling and gathering core samples there. Mysterious rocks created by magma. A second paper that was published in Science clarifies a persistent Martian riddle. Mars orbiters discovered an olivine-rich rock formation in the past. This structure stretches from the interior margin of Jezero crater into the surrounding area and is approximately 27,000 square miles, 70,000 square kilometers, in size, or almost the size of South Carolina. The abundance of olivine over such a broad area of the surface has been explained by a number of theories put up by scientists, including meteorite impacts, volcanic eruptions, and sedimentary processes. Another hypothesis holds that the olivine developed deep below from molten rock that was slowly cooling and then exposed over time by erosion. The most likely answer, according to Yang Liu and her co-authors from NASA's Jet Propulsion Laboratory in Southern California, is the last one. The scientists focused on the huge grain size of the olivine as well as the rock's chemistry and texture after persistently abrading a rock to reveal its composition. They discovered the olivine grains in the area measure 1 to 3 millimeters using Perseverance's Planetary instrument for X-ray lithochemistry, or PIXL, which is significantly larger than would be predicted for olivine that formed in fast-cooling lava near the planet's surface. According to Liu, the big crystal size and homogeneous composition in the particular rock texture necessitate a very slow cooling environment. Therefore, it is most likely that Jezero's magma wasn't exploding on the surface. Innovative science tools. The two Science Advances papers describe the results of scientific tools that contributed to the discovery that the crater floor is covered in igneous materials. The equipment consists of the SuperCam laser from Perseverance and the RIMFAX radar imager for Mars Subsurface Experiment ground-penetrating radar. A target as small as a pencil tip can be zapped by SuperCam's rock vaporizing laser from a distance of up to 20 feet, 7 meters. It uses a visible light spectrometer to analyze the resultant vapor and determine the chemical makeup of the rock. During Perseverance's first 10 months on Mars, SuperCam zapped 1,450 sites, aiding researchers in their conclusion on the presence of igneous rocks on the crater floor. Additionally, SuperCam employed near-infrared light to discover that water affected minerals in the crater floor rocks. It is the first sensor on Mars with that capabilities. However, the combination of laser and infrared studies showed that the changes were not widespread across the crater bottom. This is all for today. Thank you for staying with us. Don't forget to like and subscribe our channel. See you soon.